Hey everybody, and welcome to our first online lesson. So the unit that we're going to be covering is Unit 7, Linear Relations. Now, before we actually dive into everything that we're going to be talking about and going through, I want to just cover a couple things first. So first off, what I want you to do, if you haven't done so already, is double click on this Word document in your class OneNote, and that'll allow you to download the document and enable editing, but more importantly, for anybody who'd like to print off the document, you can print it off from there and you can follow along with us as we go through this. If you have any questions as we are going through this, please feel free to email me, but what I would suggest first is watch the entire video just in case I answered those questions along the way. So you can watch the entire video, and if you're still unclear on some of the concepts, please let me know, and then I'll go through them with you as well. So the topic that we're going to be covering today is the substitution in creating a table of values. So we're going to be looking specifically at the table of values today and how we set this up, how we fill in the table of values. Now, the most important thing that you can do is pause the video as I'm going through. So if I've already filled in some of the blanks, you can pause the video and get caught up to where we're at. But most importantly, you can also try the practice questions ahead of me and then watch the video to make sure your understanding is clear of what's going on. So when graphing the equations of a line, it helps to first create a table of values. So the table of values is this part right down here. The table of values shows us for specific values of x. So when we choose a value of x, we're going to find out what the corresponding y value is. So to calculate the y value, we're going to substitute. Now, when we're substituting, we're going to be using brackets. So when we're substituting in for the x value, we're going to be putting brackets and then the number that we chose in for that x value. So we're going to do that by using brackets. Now, the equation that we're going to be using for this part here is this one that follows. So y equals 2x plus 3. So what I'm going to start off with is, well, just writing out this equation. So y equals 2x plus 3. This is the equation that we're going to use to solve for this. Now, if I look back at this table of values here, I can look at the input, which is going to be our x value, and the output. So what we're going to get as a result of this for y. So I have 7 boxes vertically here. So I'm going to split this so that my 0 is in the middle. So that means I'm going to start with -3, -2, -1, and then go to 1, 2, and 3. I'm going to be doing this for almost all of the problems just for the ease and consistency so that you can see the change in the y and see the change between the different questions. So going back to this here, now as we set up above, we're going to be using brackets and inputting the value of x. So the first value that we chose for x was -3. And then we'll finish the question. So we have y equals 2 multiplied by -3 plus 3. So we'll continue down where y equals now 2 multiplied by -3 is going to result in -6 plus 3. Taking this further, y equals -6 plus 3. So we're going to end up with -3. Now, if I slide back over to my table of values, the value that I inputted for x was -3, and our output, so our y value, resulted in a value of -3 as well. We're going to do this for 3 different examples, so we're going to continue down the x values for 3 different times. So again, same equation, y equals 2x plus 3. Now y equals 2. Now we're using an x value of -2 because we're working down the vertical column plus 3. So take this further, y equals 2 multiplied by negative 2, which is going to result in negative 4 plus 3. Now, y equals negative 4 plus 3, which will leave you with negative 1. So if I return back to my table of values, when I used an input, so my x value of negative 2, I was left with an output, so my y of negative 1. Now we're going to do this again for another example to see if there's a pattern. Now doing linear relations, there should be a pattern that presents itself. So, same equation is used. We're going to have y equals 2 multiplied. Now we're going to put in negative 1 for our x value plus 3. Y equals 2 times negative 1 results in negative 2 plus 3. And we have y equals negative 2 plus 3 will leave you with positive 1. So back to my table of values here. Well, negative 1 was my x value, and it resulted in a value of 1. So you can see that we increased by plus 1 in our x value because we chose to increase by plus 1 each time. And this resulted in our y value to increase by plus 2 every time. So we can see that there's a common trend here that it's increasing by plus 2 each time. So when we had negative 1, it resulted in a 1. If we have 0, well, 1 plus 2 is going to lead us to 3. 3 plus 2 is going to lead us to 5. 5 plus 2 is 7, and 7 plus 2 is 9. So that's going to help us fill in the rest of our table of values because we know what the change is for y every time we increase the x by 1. So that's our thing that we have to look for every time that we're solving for an equation is what the change is going to be because of the x value we chose. So when we're looking at our next example here, we have y equals 5x subtract 2. So I'm going to go over and write down y equals 5x subtract 2. Now, y equals 5. In here, we're going to have to choose what our x value is going to be. Well, we have the same setup again with 7 vertical boxes. So I'm going to start with 0 in the middle, negative 2, negative 1, 1, 2, 3. I just find that this gives you a nice look at the positives and the negatives to go through. So we're starting with negative 3 again. Subtract 2. And we'll have y equals 5 multiplied by negative 3, which results in negative 15. Subtract 2. Continue this down. Y equals now negative 15 subtract 2 gives me negative 17. So when we chose an x value of negative 3, so chose an x value of negative 3, we ended up with a y value of negative 17. So again, over here, we know we chose values that are increasing by plus 1 each time. But we still have to figure out what our common trend is for the y value. So we'll continue doing 3 examples to figure this part out. So y equals 5x, subtract 2. Y equals 5. Now we're going to input the brackets, and we're going to input our new x value, which will be negative 2. Subtract 2. Take this further. Y equals 5 multiplied by negative 2 is negative 10. Subtract 2. Now y equals negative 10 subtract 2 gives you negative 12. So when we inputted an x value of negative 2, it resulted in a y value of negative 12. So we have a change of plus 5. Now let's do our third one to make sure this is true. So y equals 5x subtract 2, y equals 5x. Now we're inputting our x value, so our next x value that we're going to be using is negative 1, subtract 2, y equals 5 multiplied by negative 1 gives you negative 5, subtract 2. Take this further, you have y equals negative 5, subtract 2, which leaves you with negative 7. So back over to our table of values here, and we're looking at our x value of negative 1 resulted in a y value of negative 7. So is this still true here where we had negative 12 to negative 7? Well, our change was plus 5. So that's going to be our change consistently every time we increase the x value of 1. So if we're increasing the x value of 1, now we're at 0, and negative 7 plus 5 leaves you with negative 2. Negative 2 plus 5 gives you 3. 3 plus 5 gives you 8. 8 plus 5 gives you 13. So now, because we found out that every time we change our x value by plus 1, our y value changes by plus 5, we are able to fill in the rest of the table. Now we'll be sliding to the next. You're going to have to flip over your page. And we're going to be looking at the example of y equals negative 3x plus 6. Now, a good thing to note here is we can put any value we want in for x. So we can put any value in. So we can change our x value to anything that we want. We can put any value in for x there. But in terms of me being consistent and just my pet peeve of staying consistent, we're going to be keeping it as negative 3, negative 2, negative 1, 0, 1, 2, and 3. So if you wanted though, you could choose any x value you want, and then you do 3 examples just to find what that change is going to be. And it will always be consistent because we're looking at linear relations here. So we're now using the equation y equals negative 3x plus 6, y equals negative 3, and we've inputted our x value of negative 3 plus 6. Take this further, negative times a negative will result in a positive number, so you have 3 times 3, which gives you 9 plus 6. And to finish this off, 9 plus 6 will give you 15. So when we chose an x value of negative 3, we ended up with a y value of 15. Same equation here. We're going to use y equals negative 3, and our x value is going to be negative 2 plus 6. Y equals negative 3 times negative 2 gives you positive 6 plus 6. Y equals 6 plus 6 gives you 12. So when we chose an x value of negative 2, we got a y value positive 12. And to do our third one here, we're using the same equation. Now y equals, the only thing that we're changing is our x value. So we're using an x value of negative 1 now, plus 6. Y equals negative 3 multiplied by negative 1 gives you positive 3 plus 6. Y equals 3 plus 6 gives you 9. So move over again, back to your table of values. You have negative 1 as your x value and get a positive 9. Now, our change here was plus 1, and that again is because we chose that to be our change for the x value. Now, this is our result of increasing by our x value of 1. It's a negative 3 here. So we're decreasing by 3 every time you increase the x value of 1. Same thing here. From 12 to 9, it decreased by 3. So you took 3 away. Now, if we're following that pattern, we have 9, and we're taking away 3, we're going to end up with 6. 6 take away 3 gives you 3. 3 take away 3 leaves you with 0. And 0 take away 3 gives you negative 3. So that allowed us to fill in the rest of our table here. Now, for this last problem here, if you haven't at any point paused the video and tried any of the examples on your own, I do encourage you to do that. But if you're still unclear, you can follow along with me or you can send me an email as well. But for this last one, there's one special note that I want to pay attention to, is looking at the denominator. So we may want to choose values according to the denominator when we're looking at our x value. So I'm just going to make a note of that here, that we may want to choose values according to the denominator. Perfect. So we're going to choose values according to the denominator. So we're still starting with that negative 3, but our denominator is a 3. So I'm going to be changing my x value by 3 each time. So now I'm going to be going positive 3, which will give me a 0. So increased by 3 there, so plus 3 was our change. This will go to 3, this will go to 6, this will go to 9, 12, and 15. So notice our x values are different for this question here. Now, with the equation that we have y equals 1 over 3 x plus 6. So we're looking for a third of x every time. So y equals 1 over 3, and we're going to input our value for x. Now, our value that we're going to be using is, in brackets, negative 3 over 1, because our denominator would always be 1 if there's not 1 listed there. And then we finish the equation by adding our plus 6. Now y equals, now when we multiply these fractions together, it results in negative 3 over 3 plus 6. Well, y equals negative 3 divided by 3 leaves you with negative 1 plus 6. Y equals negative 1 plus 6 leaves you with 5. So when we chose an x value of negative 3, it resulted in a y value of 5. Taking this further, y equals 1 over 3 x plus 6. So y equals 1/3 in brackets. Now, our next x value is going to be 0. So put in our 0 plus 6. Now, just because we know anything that we multiply by 0 is going to result in a 0, we can skip ahead and put a 0 here, plus 6. Well, y equals positive 6. So when 0 was our x value, it resulted in a y value of positive 6. And we'll do one more so that we can look and make sure that we are finding our pattern here. So what's our common trend? So y equals 1/3 x plus 6. So y equals 1 over 3. In brackets, we're going to be using 3 this time over 1. Again, our denominator is 1 whenever it's not listed because dividing by 1 is still itself, plus 6. Y equals, now multiplying these together, we get 3 over 3 plus 6. Y equals, now 3 divided by 3 leaves you with a positive 1 plus 6. So y equals 1 plus 6 makes 7. So, moving back to our table of values here, when our x value was 3, our y value was 7. So, what's our common pattern here? What's our common trend? Well, every time it's increasing by plus 1. Plus 1. So, our next y value would be 8, 9, 10, and 11. So, if you do have any questions at this point, please feel free to email me. You can also replay the video all over again and see if that clears up any of your misunderstandings. But most importantly, if you do have any questions, please feel free to email me.